Welcome back to the part 2 of recursion series. In this video we'll talk about tail recursion and non-tail recursion. So let's jump right in. Now we talk about tail recursion. This is when recursive call is the last thing that happened before the function returns. Here's an example. In this example we get the inputs as 5 to the end value and 1 as the accumulator. So we go to this function and check if the n is equals to 0. So the first we have 5 and 1. So 5 is not equal to 0, so it goes to this function, and n minus 1 we get n minus 1 we get 4, and n into accumulator will be 4 and 5, and now we have n value as 4, and then we have n minus 1 would be 3, and n into accumulator would be 20, and then we have 3 to 20, 3 and 20. Now we have n value 3, and go 3 minus 1 would be 2, and the accumulator would be 20 into 3 would be 60, and then we go to the next part. The accumulator would be 2, and we get n minus 1 would be 1, and the accumulator would be 120, and we go again, and now we have 0 as the n value. So 0 is equal to 0. Now we return the accumulator, and output will show us 120. So in tail recursion, no extra computation happens after recursive call. This makes it memory efficient because the compiler can optimize it to use exact stack space. Finally, we have non-tail recursion. Non-tail recursion is where recursive call is followed by additional computation. Here's an example. In this example, we get 5 as the input, and when we input 5, after do this calculation, we get 4, 3, 2 and 1 and 0. When we got 0, it means the base condition is reached. Once the base condition is reached, in non-tail recursion, the recursion starts unwinding. During this phase, the results are computed reverse order. So it returns 1, and 1 into 1 would be 1, and then it goes to the next recursion. It would be 1 into 2, it would be 2, and then it return 2, and 2 into 3 would be 6, and it will return 6 to the next recursion, and it will be 6 into 4, that would be 24, and then it would go to 24 to 5, and then it would be 120. So we will get the output as 120 after this recursion. In here, the multiplication operation happens after the recursive call returns, so it uses more stack space. This is less efficient than the tail recursion. So let's wrap up the discussion of recursion types. Now you know about the direct, indirect, tail and non-tail recursion with our examples. If you found this video helpful, like the video and subscribe to my channel. Thank you.